Alright, on the last lesson I jumped the gun a little bit and showed you one example of estimating square roots, so I'm going to show you that again, but this is Honors Purple Chapter 1, Lesson 9. We'll be doing the guided practice off page 84. So they really want you on this first section to round to the nearest integer. They only want to know, is it closer to the one below or closer to the one above it. So I'm going to go through the whole process with a couple of these, and then we'll just go to the nearest one. So I realize that 28, I'm doing a square root, so 28 is between the square root of 25, which is 5, right? And 36, which is 6. So I already know it's going to be 5 point something, okay? Because it's got to be lower than 6. Alright, so between 25 and 36, I do a subtraction problem. There are 11 numbers in between 25 and 36. If I do this subtraction problem, 28 minus 25, I'll find out of those 11 steps to get to 36, I'm only 3 steps along the way. That will tell you it's going to be closer to 5, because what would be right in the middle would be 5.5 steps. We're not to there, we're on the lower side of this, so it would round down to 5. But I'll go ahead and show you that anyway. So I am 3/11ths of the way, so if you divide 3 by 11, you're going to get 0.27 repeating. So 5.27 repeating is a pretty close estimate. Obviously 0.27 repeating is going to make it round down to 5, so to the nearest whole number that would be 5. I'll do 28 square root on my calculator just to show you exactly what it is. It is 5.2915, so 0.27 repeating is a pretty accurate estimate, obviously closer to 5 than 6. So I'll do that one more time. Okay, so 135 is between 11 squared, which is 121, right? And 12 squared, which is 144. I'm already thinking it might be a little bit closer to the second one, so let's just check it and make sure. So between 121 and 144, when I do that subtraction problem, there are 23 numbers. If I do this subtraction problem, 135 minus 121, I'm getting 14. So see, I'm more than halfway to that next one, so this one's going to round to 12 eventually, right? But I could, of course, do 14 23rds. 14 divided by 23 is 0.608. So I would go back to this one and say it's roughly 11.608. ... Not exactly. And then if I actually did it 135, took the square root of it, I would get 11.61. So once again, a pretty good estimate for it. Obviously, the 0.6 makes it round up to 12. Alright, so let's look at this. We'll just do this one to the nearest whole number so you see that process as well. So it's between 6 squared, which is 36, right? And 7 squared, which is 49. It is far closer to 36 than it is to 49, right? It's 2.7 away from this, and it's 10.3 away from this, so it's obviously going to round down to 6. Cube root. Okay, so to do cube roots, really, once again, I'm going to show you this list. This is a list that should be kind of in your head eventually. Perfect squares. This is 1 times 1, 2 times 2, 3 times 3, 4 times 4. Maybe I should say it this way. 5 times itself, 6 times itself, 7 times itself. Maybe I should say it this way. 8 squared, 9 squared, 10 squared, 11 squared, so on and so forth. So that should be a group of numbers that you recognize as perfect squares. Perfect cubes people don't recognize as well, but this is 1 times itself again. This is 2 times itself again. Or maybe I should say 3 times 3 times 3, or 4 times 4 times 4, or maybe I say 5 cubed, 6 cubed, 7 cubed, 8 cubed, 9 cubed, 10 cubed, so on and so forth. So people don't recognize those numbers quite as readily, but they're ones that we should definitely get to know during this chapter. Alright. So when I look for cube root of 51, so let me show you that list again. Do you see that the cube root is between these two right here? Which one's it closer to? Well, 51 would be 24 away from this one and be 13 away from this one. So whatever this is, that's what we're going to round to. And that is 1 to the third, 2 to the third, 3 to the third, 4 to the third. So that is going to estimate to 4 if we round to the nearest whole number. 200, well, 200's, if I look back at my list, 200 is between 125 and 216. Right? If I wrote it, I could write it right in there just so you see it. It's 75 away from this one. It's only 16 away from this one, so it's going to round up to whatever this one was. So remember, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So we're going to round that to 6 to the nearest one. and the cube root of 95. So go back to your list. 95 would be right in between these two, right? When I subtract, I get that it's 31 away from this one. It is 30 away from this one. It's pretty close, but which one is it closer to? It's closer to this 125, and so it's going to round up to 5, but barely. Almost right in the middle. And that's how we do estimating to the nearest whole number of square roots and cube roots. The process to do this, to get a cube root, is a little bit uglier. I'm not sure that we're going to show you that at this point.